Hello everyone, my name is Alexei and this is the continuation for the playlist of videos. Well, today, in the past video we have seen cases for when we have one random variable and the analysis that we do in that. But what happens if we have more than one? What if we have two random variables inside our data? What can we do? Well, there is something called generally distributed random variables, and this is some of the things that we have to consider. So, for example, in the past we have this probability that what is the probability that a certain event X happens. Now we'll have a joint probability that is Px y. Now, in these cases, we need to accomplish some. We need to satisfy some conditions so we can have a normalized probability and some and that can be done in the reality. For example. This probability, the probability of all of these cases, as we have seen, it must be must satisfy is that be lower than 1. Because if we, like example, have this part of x and this part of y, and we check the total probability, none of these values can have a value much more greater than 1, because if not, the random probability function is not normalized. Other thing is, as we have seen, is that since this is normalized, the sum of all the probabilities, the sum of all the joint probabilities must be equal to 1. So the second part that we need to accomplish is this: the sum over all values of x, the sum over all values of y, of the joint function probability px must be equal to 1. This must be always satisfied so we can have a normalized probability function and we can get a result which we can analyze with our methods. Okay. Now, for example, let's say that we have a random value x that is of this one: 0, 1, 2, 3, and a y: 0, 1, 2, 3. Now, this in some case could be like our random variables that we are analyzing, and these are like the possible values that are in each. Now, if we assume that there are equal likeness, then to grab a value of x, the probability of each one will be 1/4, no? Because we have 4 values, and also in this part. So each part has its own probability. Now, what if we have another function, a function that unites these both x and y? For example, we have we would like for to get this sum. So what does this mean? This means that we want to get all the sums that in these values give us a value of 5. So which values of these will give us a value of 5? So we know, looking at the data, that only values of 2 plus 3 or 3 plus 2 will give us a value of 5. So this means that we have two cases in this part. This case with here, and this case with here, and the other ones are not satisfied by the condition. So that means that given that we need to have a pair event, which a pair event is some value of x with some value of y, each we can calculate the probability in an easy way, because if you have two values, I mean x and y, will be the 2 plus 3, we need to sum the probability of this product here. So x2 to 1. And we know, since our equal likeness is 1/4, and since we are assuming also, we can also assume that are independent events. So 1/4 times 1/4 plus 1/4 times 1/4. So here we will obtain will be equal to 1/4 if we do the math. We will obtain a probability of two independent variables, or two independent random variables summing a value equal to 5, given that we have this data. So this is why these kind of joint probability problems can be really useful. Okay, there is other topic that appears when we have a joint probability, that is called marginal probability. Okay, marginal probability. So first I will show you the mathematical equation that it is equal to PA of A is equal to the sum of the values of the set of B of the joint probability AB. And yes, well, value what? Okay. This is a marginal probability. There is a really visual way you can see it. For example, imagine we have this table. We have this, we have A, B, A1, A2, A3, B1, B2, B3, and BB, BA. So imagine that we have an event B1 with each part that is have a probability of 9/10. This has 2 tenths, 3 tenths. Now, what happens in a marginal probability, as we can see, is that we are summing all the events given that we have a AJ. For example, in this part, we can have an event B1 that is going to happen, and we are analyzing all the cases in which B1 happens. And this is the 3 cases in which B1 will be happening with A1, with A2, A3, and we have already the values of each probability. So according to this equation, what we're going to do is simply sum all these columns. And after summing this column, we lose 14 tenths. That is will be the probability of event A1, probability of event A1 happening in total. So this is marginal probability. Okay, the next is, well, all these cases are for discrete values, but what happens if we have a continuous random variables? What if it stops being so discretized? So it's a really easy consideration, because the only thing that we have to do really is that we need to substitute the summatory symbol that we have for integration part. So for example, if we have the joint probability Px of y, giving some interval of, for example, in an interval A, that like the joint probabilities in this rectangle of A, then this will be equal to the double integration of a probability function of x and y dx dy over all interval parts of A. So this is the same as we have seen. Now that instead of having, for example, and we have like x from 1 to 3 and j value in discretized values, now we have an integration area. So for example, now x going from 0 to 3 and j from 0 to 2, and this will give us an integration rectangle, which will be the one that we're going to put in this part and do the calculations. And the rest part, for example, the marginal probability and all that kind of stuff is basically the same, just that we are replacing all the symmetry with an integration symbol. Now, also independent variable. If we have independent variables, so for example, in the discrete value part we have px times py. In the continuous, we have the symbol that represents continuous value with an f now, and then only the multiplication of this part. So also it happens with conditional probability and what kind of thing. So it's really easy to generalize. You only need to know the calculus tool set for solving this problem, but it's the same. So thank you and see you in the next video.